So today we have our first session on AI in mixed reality, and for today's session we have our speaker Manorama Jha. She is a mixed reality SD at Grade and she specializes in deep learning based computer vision algorithms for real time 3D reconstruction localization and tracking for virtual augmented and mixed reality applications. She has more than 5 years of experience in developing extended reality applications using Microsoft HoloLens, Oculus, ARCore, Unity, and Unreal Engine. She is well known in the AI and computer vision communities of India for her courses and blogs on AR, VR, and MR, and her work as a moderator for IDLI, which is Indian Deep Learning Initiative, and it's a Facebook community for of 10,000 plus AI practitioners. And in her free time, she is a wonderful painter, and her genres are hyperrealism, surrealism, and abstract. So you can stay tuned for next session. That is the engineering reality of mixed reality. That is on Friday, May 6, 2020 on 11 at 11 a.m. EDT. That is 8:30 p.m. IST. Thank you, and let's give it up for Manorama Jha. Over to you, Manorama. Thank you.
Yeah. Thank you, Shrishti, for the wonderful introduction. So I'll be sharing my screen. Okay. So yeah, thank you everyone. Thank you for joining this session. And today we'll be talking about applications. Like this is an intro series, like Srishti mentioned. So today mostly we'll be focusing on what is extended reality, what are the components in extended reality, and so moving forward, yeah. So before even jumping into AR, VR, or MR, so I would like everyone to recall our childhood. So let's recall our childhood. So like me, I am like from a middle class household from Kolkata. So when I was like, when we got introduced to science or history or geography, so we used to read about Himalayas, we used to read about Sahara Desert, or we used to read about equatorial rainforest. So we got introduced to like the creatures, the animals, or maybe we can say the dinosaur, which is already extinct. We cannot see them anymore, or we can say we also saw like we also got introduced to the mighty Himalayas. So these were like very imaginary. So we were reading it in textbook, and we used, like, I basically used to think that okay, how does Himalaya look? If I'm in front of Himalaya, how does it will be? Because I wanted, like me as a kid, I always wanted everything to come out of my book and appear in front of me. Like that is like my imagination. I like if we want to say in a simple word, I wanted my imagination to convert into reality so that I can experience them. But I having like limited access to internet or like resources, so my resources were limited to textbooks. So like having the limited resources around me, so I was like there were like many like questions which were unanswered, many questions, many of my imagination which were like just I kept aside, and I just went like ahead in my life studying, and many things like came, like many knowledge, many information came up, but those were unanswered. So yeah, this is like not only me, not only for me, for many students, for many kids, like this happens. Like how will like they will be curious how Himalaya looks. Oh, okay, how dinosaur will be looking like. Yeah, how does it look? If it is in front of me, what will happen? So can I feel it? Can I feel the moment? So there are many things that makes people curious. So those were like unanswered, like how because many people don't have the access to travel to Himalayas. Neither many people will have not we cannot say access. They cannot afford to travel and visit Himalaya when they are a kid, or travel and visit Africa when they are a kid. So yeah, so this is where everything stops and people just move ahead in life. So now what happened, like now these all were not answered until I joined my engineering, and after that I joined IIT Kharagpur. So I joined IIT Kharagpur as a research assistant, and there I started working on virtual reality. So the first day when the project was assigned to me, I was literally I was not aware about what is VR, what do we do with VR, how does VR look? How do we feel like when we are working with the device? What actually happens? That was a black box for me. So after that, when I started working on that, so all my childhood questions started coming into reality. All my childhood, that curious ideas that used to come in my mind started coming into reality. So after that, like I started working on VR, and then I joined Gridraster. So I started working on AR and MR. So we can. So let me just like I'm telling multiple terms. So AR, VR is nothing but virtual reality. AR is nothing but augmented reality, and MR is nothing but mixed reality. So these you can consider these are like brother and sister from the same ecosystem, that is extended reality, that I will be talking about today in my next slides. So yeah, so this was like I wanted everyone to imagine, go back to to their childhood and think like how whenever you got introduced to, suppose the like Great Wall of China, suppose Great Wall of China, suppose dinosaur, if it is Himalayas or anything, even if it is a biology. So if you want to see how the heart pumps, so you cannot like it is just in the textbook, you cannot feel it, you cannot see it, it is just 2D. How do it look in 3D? So those things are answered by this the extended reality uh, ecosystem that I'll just introduce you in next few slides. So okay, so let's move. So I'll just have a brief of the plan of my presentation. So today I'll be talking about, like I'll just introduce the different segments of extended reality, that is VR, MR, and AR. And also I'll just give a brief about application of extended reality, and I'll take an example of a device that for mixed reality. And having that, I'll try to explain how a typical mixed reality pipeline works. What are the sensors? How does it work? How does AI come into the picture? And how AI is changing the this extended reality ecosystem. So let's move. So I'll start with definitions, just starting from scratch. So now we have like when I say VR, MR, or AR, so there is something called environment. So now environment, if we divide it into two parts, so it will be synthetic and it will be real. So real environment is nothing but like the environment that people are seeing around. And now the second environment is the synthetic environment. So the VR, the virtual reality, that is part of the synthetic environment where the user is placed in a virtual environment that is generated synthetically using digital assets. So when I say VR, so it doesn't have access to the real world at all. So there will be a device, maybe many people are aware of VR headsets, that is Oculus, that is HTC Vive. Maybe many people have seen them in malls. So they have games. So you wear the device and you get detached from the real world. So that is what is virtual reality. Next comes the real environment. So for real environment, I can give you a very good example. But before that, I'll just introduce you what is augmented or mixed reality. So in augmented or mixed reality, the user is provided with an augmented view of the real environment, where digital asset coexist seamlessly with the real object. So the best example of this real world is your smartphone. So now like you might be having those experiences on your Amazon, Myntra, or any shopping experience. The best example is now in COVID times, many people when they were not able to go to IKEA or any furniture shop to buy furniture for their home. So basically, they were trying to just open their smartphone, and whatever furniture they were trying to like they like, so they will just drag and drop in your environment. So you have the camera access, so you will have a digital asset of the suppose it is a chair. So you will have a digital asset of the chair, and you can place it anywhere in the room, and you can feel like how does it look. So it minimizes your travel. It reduces your it minimizes your time. It is time saving. You don't have to travel also. Like when you are placing the chair, you can actually move around and see how it looks in your room. So this is where we say that this is an augmented view of your real world when you are placing a digital asset, like I just mentioned. So your digital asset is a chair, and your real world is your home. So this is where we augment the environment. So here comes the augmented, like this is a like proper definition and example of augmented and mixed reality. So going forward, I'll just give few examples of MR, AR, and VR. First example, first use case or application can be in education or entertainment sector. So now in education, so nowadays in India, I haven't seen many places that in schools like people are using VR or MR headset, but abroad I have like seen many places where they have a lab where they set up the VR or the MR headset, and they just launch an app and say kids like, okay, can you see, like in this GIF you can see that every part of the body is labeled. So this helps in like this helps in making the learning process much faster, and it is very interactive, and also it is very appealing to the audience. And audience will be our kids, or it can be anyone, it can be teachers also, it can be like any people. So this was one of the application, might be everyone has experienced it, that is like in education or entertainment. Second comes is in the manufacturing. So in manufacturing, mostly nowadays people are using AR or MR devices. So this actually MR or AR devices reduces the cost. Like I said, for our chair, that augmented chair use case. So where you are just trying to place the chair, you don't have to go to IKEA or any other store, and you have to go search and then buy. You can just place your digital asset. That reduces your time. So it is not exact the same use case here, but what happens is now you have a, like you have a, suppose you have a bike here, and that is in real world, and that is just manufactured. So that is just designed maybe, and now you have a digital asset of a bike. So now you want to see the defect. Where is the defect? Because before manufacturing, there will be a round of testing. So where they try to find, okay, there is an error. Even the small error matters. So there will be a team who will be checking this. So now to do that, people have started using AR or MR across the world in many segments, like many places. Like it can be either your automobile or aerospace. So they have started using this. So this reduces the time, and this also reduces your, like people don't have to travel to a different part of the world to just to evaluate this. They can be literally in any part of the world, and they can just evaluate the uh, like the defects, or the, we can say, they can just analyze where is the issue before manufacturing the products. So this is where it helps in manufacturing. The next one, that is the most important. So many people might, that is healthcare. First of all, it is one of the application, most important application is healthcare. where many people might be aware about robotic surgery. Even before robotic surgery, it is basically it is used in the medical sector, where this MR or AR devices are being used to train the students before they become a doctor. So where they can see where the issue is, or where they can just, like, if you have a scan, so you can actually see your scans in 3D. Nowadays, I think in India also you get a digital asset of, suppose it is a baby, or suppose you have a issue in the heart, so you get a digital asset that actually you can open it in your laptop or any other device, and you can see where the issue is in 3D. You can actually rotate the 3D asset and you can analyze it. So previously we were getting it in 2D. Now we also get it in 3D. So best example is a baby. You can get a 3D asset of a baby, and you can just see how it is growing every month. So this is where this is how it helps in healthcare. MR and VR, how it is helping in healthcare. Now I'll try to explain how mixed reality device, how is the hardware of mixed reality device. For that, I'll take example of the most used mixed reality device, that is HoloLens 2. HoloLens 1 or HoloLens 2. The HoloLens 2 is the upgraded version of HoloLens 1. So I'll just talk about what are the features and what are the sensors available in this device and how they are used. So first is spatial mapping, localization, and gesture recognition. So these are taken care by the camera, the RGB camera, or we can say the color camera, the depth camera, and the IMU sensors that will have different uh, uh, different sensors that are present on the device. Second is the display. So there are like two laser projector beam stereo images directly into the user eyes for an immersive experience. The display system tracks the eye and the head movement of the user and adapt it in real time for persistence of vision. Third comes the hands-free communication using natural language. So there are array of microphones and stereo speakers that supports a natural language control interference for hands-free communication. So basically, this device has these features which helps us in that gives us an immersive experience, and it like now you can make out how it helps in different use cases that I just talked about. It even has a microphone, so you can just ask like move the object. Suppose there is a cube, you can ask the device like move this object by 2 meters. So yeah, or you can say like start capture, or you can say start recording. So it will do it automatically. You don't have to even interact with the hologram or the UI. So it has that feature as well. Next, I'll be talking about how we can analyze a typical mixed reality pipeline. So this part of the presentation will cover how AI will, like you can see AI will be slowly entering into MR. So I just introduce about that. So first comes the 3D scene understanding and spatial mapping. So the first feature comes the ground plane detection. Now that detects, basically it detects and segment out horizontal planes where objects can be anchored. This is important for setting up the global coordinate system. Second comes the structure for motion that constructs a 3D point cloud from sequence post images scans of an object or environment. Third comes the 3D point cloud segmentation. So here it detects and segment out different categories of object in a 3D point cloud. Fourth comes the tracking. So it is like detecting the same object across multiple frames and estimate how the object moves through the scene. Fifth comes the localization, like estimating your current position or orientation in the map using odometry and tracking. Now comes the second part of the mixed reality pipeline, that is the 3D rendering. So when I said like cube, or when I said so here, yeah, let's go back to the childhood story. So now suppose we want to see Himalaya, or we want to see dinosaur. So how that will happen? That happens from this part of mixed reality, like this feature of mixed reality or AR devices, the 3D rendering, it renders, it actually renders. So now you can have a digital asset of Himalaya that can be as big as your home, or as big as two-floored storied apartment, and you can render it. You can literally render it and walk around and see how it looks. Even you can move it. Even you can go to the top of the Himalaya and you can feel that how it looks. So those things are there. Even for height, that will be much better in a VR device, where you are like, you can feel that you are really in Himalaya, or you're really at top of the Everest. So it's on you which device you want to choose for rendering. For now, like I'll be focusing on mixed reality pipeline. So I'll just go ahead with explaining you the different features available for 3D rendering. So first comes anchoring. Anchoring, like it is attaching like digital models to fixed points, that is anchors on real world surfaces, and making sure that the digital model does not shift its position or orientation as the user viewpoint changes. Second comes the alignment. Alignment is nothing but overlaying a virtual model on an object on top of the real world instance of the same object, such that the position, orientation, and the scale of the virtual world matches perfectly with the pose and dimension of the real world. So here comes like here I'll just pause and tell that I was giving an example, I think, in the application slide, where I just said that if we have a motorbike, like motorbike or any bicycle or any car, and you were trying, I was telling that we can just render a digital asset of the same model and see where the defect is. That is like that happens before manufacturing. So it is where it comes like overlaying a virtual model of an object on top of the real world. So you will have a bike in real world, and you'll have a digital asset of the bike of the same size, same dimension, same pose, and you can just overlay it and see where the defect is before manufacturing. Third comes the occlusion. So occlusion, it is nothing but detecting a 3D object correctly, even when part of it is occluded behind an obstacle. This is particularly important for tracking. So any tracking devices, this is a very important feature. Fourth comes the remote rendering. Rendering high polygon photorealistic 3D object is crucial for an immersive MR experience, and it is difficult to achieve within limited compute budget of the headset. We must render the 3D scenes in the cloud and stream the user's current view to the headset. The third segment of any MR device is manipulation and interaction. Like the first comes numerical integration. Efficient numerical integration is key to accurate physics simulation for modeling interactions. Second comes collision detection and contact modeling. So it is nothing but modeling collision and contact is a challenging task that is again crucial in many MR tasks. Third comes the material properties. So material properties must be properly modeled for representing surfaces of virtual objects correctly and modeling interactions between real and virtual objects. Constraint implementation. So physics simulation must take into account physics constraints. These must be detected and implemented properly. Multimedia gesture recognition. So speech recognition, natural language understanding, and detection of hand gestures are crucial components of a MR system. So manipulation and interaction, I'll just give a short brief. So it is basically, if you are like I just said, Himalaya. So I'll just take the same example. So we are on the same like track. If it is Himalaya and you just and you are 1 meter away, like it is 1 meter ahead of you in the positive Z direction. Now you want to move it 15 meters ahead. Suppose you want to move it a bit far, like that will be, if it is 5, so it will be plus 20, like plus 20 a meter or centimeter in your z direction ahead of you. So in that case, you can either like hold it and move it, or what you can do, there will be there are multiple toggle options where you can just uh, touch and just press like positive set how much you want. So there will be option like if you want to move by 10 centimeter, or you want to move by 10 meter or centimeter, anything. The units depends on your use cases. So you can just move it, or if you want, like, okay, I want to, there is a cube, you want to turn it by 90 degrees, so there will be two options, like you can either use the options to rotate it by 90 degrees, or you can even touch, actually you can touch the cube and just rotate it by your hand. So it's like, it is very realistic, and you will feel like that will give you a great immersive experience. So I have experienced that over time, like I experience it on a day-to-day basis. So like that is really really like that will make you curious. So I'm till today I'm curious about the MR pipeline. So yeah, so now yeah, that's all for today, and to be continued, like in the my next part of the series, I'll be talking more about AI, more about how to make those like whatever use cases I just mentioned, how to make that happen, and how people in the AI and MR community or AI community are making that happen, and how this technology is growing. So people basically they name extended reality as emerging technologies in many conferences or any forums. They have a tag emerging technology. How this is changing the entire world, and in next 10 years, how this is going to change not only industry, how it is going to change your education, how it is going to change your healthcare. So those things I will be covering in my next talk. So stay tuned. Thank you, everyone.
Thanks, Manorama. So we have one question. So Norina asks, could you please give more example to differentiate between MR and AR?
Yes. So more examples for AR. So for AR you can access it through your smartphone. Like every one of us is using AR every single day. But for MR, basically you need a like headset which can do the proper computation. So I'll give you the best difference for AR or MR. So for AR, if you're using your, suppose you are using your smartphone, it don't have like good depth camera. You need depth. So even if you're placing a chair, your device should know what is the distance. Depth is nothing but the distance. So if you are placing the chair 5 centimeter or 5 meter away from you, it also needs where should you place it on the ground. So it also needs the depth or the features of your ground or wall. Like those features are required. So our smartphone won't be capable of like having those high quality sensors. So for that we need a MR device. So our MR device, like I mentioned, just introduced HoloLens 2. That is a like excellent device with good sensors, good RGB camera, with good IMU sensors as well. That gives us the exact detailing of the environment, the depth, the actual depth of the environment, the color, the textures of the environment. So this is where like it comes. You can say if you want high quality immersive experiences where you are trying to like augment your real world with rendering the digital object, then you should always go for MR. But yeah, if you are trying to use it on a like, if you are going for a device like smartphone, then you can use like AR. So sometimes people also refer to HoloLens 2 as a AR headset. So this is just the sensors that matters, and the computation.
Amazing. Thanks so much, Manorama. So we have a few more questions in the Q&A. So Sonal asks, what companies are currently providing these technologies?
What companies are providing this technology? So I work in Critraster. So we are exactly working on these technologies from last around 7 or 8 years. And there are many companies in India. I think there are very less than 10 companies who are actually working on the use cases that I mentioned. So, but abroad in Europe or USA, if you find, there are a lot of companies, a lot of startups which are working on these technologies. The best, like the big companies, the Microsoft, even Google or Apple, they have their headsets, and there is a like big team with very great people working on bringing up this device and making this device better every single day. And they also have like different use cases that they are working internally. Yeah, for like Apple, that Apple Air glasses will be available to us by either end of this year or next year. So if you take the example of MNC, Google, Microsoft, and Apple, and if you take the example of startups, so yeah, I work in a startup, and that is Critraster, and it is a US-based company, and we have headquarters in Silicon Valley. And there are many startups out there, like people can just, you can just check it out. Or yeah, you can just drop me a message. I can just send you the entire list of the companies. Yeah.
Awesome. So next question is from Andrea. She asked, do you have any books or resources that you suggest to learn more about augmented reality?
Yes. So I have a page on GitHub. Like people can maybe see, you can search it on GitHub, like where I have listed down resources for people who want to start in VR, AR, or MR. Also, you can check me out on Medium. So I have a lot of blogs. I have an entire tutorial on VR. So where there are the tutorial has 10 series, and where you can just get yourself introduced to VR, and also have few blogs on AR and MR. So blog on AR was my very first blog, so you can just give it a look, and yeah, I think that will be helpful. And on GitHub, you can check out my GitHub page. So I listed down the resources for VR and AR, but soon I'll have a page for MR as well.
Awesome. So the last question is from Martha. So she asked, any technologies, languages, or frameworks you recommend to get started in this field? So I think it's also quite similar to the previous question, but I think here it's more specific to like language, like programming language or framework per se.
Yes, yes. So programming language, if you want to get started with MR, like when you say MR technology, basically you will try to have an app that you can deploy on any AR or MR headset. So the best place to get started is Unity or Unreal. So these are the two platforms that I have been working on. So currently I'm working on Unity. So you can get started with that. And going ahead, if you want to bring on your AI experience, or you want to implement anything like segmentation or object detection, so then you can just start with Python. Simple, like everyone in our AI community uses Python. So you can start with that, and then you can plug in that with Unity, and then you can just see, like you can just go ahead. So answering your main question, you can start with Unity. So Unity has many examples that help you deploy application, AR or MR application on any devices. It can be even smartphone, HoloLens, or any UWP platform, or even Windows platform. So it has support for everything.
Amazing. So that's all the questions we had. If you have any more questions, please please save them for our next session. So in next session, Manorama will be going into more interesting topics. And thanks so much to our speaker, Manorama, for this amazing session today. Beautiful graphics, beautiful presentation. I really enjoyed it. And thanks so much to our host, Shrishti. And thanks to Aline for moderating the chat for all of us. And thanks to all the attendees for joining us today. See you next in the next session. Thank you so much. Take care. Bye.
Yeah, thank you. Thank you, everyone.